Hi everybody. So we're going to take a look at some solubility rules now. What I mean by solubility is, does it dissolve in water or not? And for this class, we're going to be kind of black and white about it. It either dissolves or it doesn't. It's really more of a spectrum, but for what we're doing, we can just keep it simple. So we've been seeing balanced chemical equations like this, and you've maybe been noticing that sometimes we have ionic compounds that are aqueous. Here's another aqueous ionic compound. And then sometimes we'll have ionic compounds that are solids, and then maybe aqueous again. So how do we know what's going on? You can find all sorts of tables of solubility rules. This one happens to come from Openstax Chemistry 2E, which is a textbook online. But we can use those tables to help us figure out, if I have a bunch of compounds, which ones are going to dissolve or be aqueous once we put them into water, and which ones are going to be solid and not mix with the water at all. So let's see how to use this table of solubilities. And again, this comes from the Openstax textbook. All right. So if I look here, I've got a first group of compounds are going to be soluble when I mix them with water. And so that means that these are going to have phases of AQ next to them in a balanced chemical equation. And so we've got all kinds of, if I've got these ions, they're going to be soluble, except if we fall into this column here, these are the ones that are going to be solid instead. So mostly aqueous, but then a few solid. And if I keep going down, we've got some insoluble compounds. These are the ones that don't dissolve so much in water, so solid. But some exceptions here. These are the ones that will stay aqueous, okay? So let's see how to use this by just looking at a few compounds here, all right? So I've got KCl, or potassium chloride. So I can go looking for either the cation or the anion on my table. So if I look down here, here is potassium, and potassium falls with aqueous, and there's no exceptions. So that tells me that this is going to dissolve in water, and I could put an aqueous symbol by it, okay? Meaning it's actually going to break into potassium ions and chloride ions in water. All right, if I look at AgBr, okay, so here is bromide, and bromide, it looks like we're going to be aqueous, except here is silver, and silver with bromide becomes solid. So that means this is solid, and it will not break into ions when I put it into water. Magnesium bicarbonate. All right, so I don't see the magnesium, but as I'm looking down here, I see the bicarbonate ion. All right, bicarbonate is aqueous, soluble in water, and there's no exceptions. So that means that this is going to be aqueous, and I could think about that being Mg2+, and then 2 of those bicarbonate ions when it goes into water. Final example I'll do with you, and then I'll leave you with a few to try. So barium carbonate, all right. I am looking for that carbonate ion. Carbonate ion is down here, and notice that carbonates default to solid or insoluble unless they're with group 1 cations. So remember on the periodic table, that's that first column, or ammonium, okay? So I was looking at barium. Barium is in group 2, so that means that my carbonates are going to be insoluble, and insoluble means it's solid, it's not going to break into ions. All right, so give it a try looking at these, and you'll have a new skill.